Hi, guys. We're going to look today and tomorrow at a PowerPoint over visible light, and you will have questions in your Canvas attached to this assignment that you will need to complete. So you might want to watch this maybe a couple times or take notes as you go, but you will need to answer questions on Canvas today and tomorrow, and those will be your assignments. Okay, so we're going to look at visible light. And while we are on this topic, we need to look at some very important questions. Where does visible light fall on what's called the electromagnetic spectrum? You should have maybe seen that yesterday on the little cartoon. The electromagnetic spectrum is massive, for lack of a better word, but visible light is just a teeny, 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 tiny bit. So you'll need to think about that as we go through here. Question number 2, how does an object's material and a light's frequency, which is its color, affect the way that light is reflected, absorbed, or transmitted? And last, how does the frequency of a light wave determine its color? So you will look at all those things in the next few days. All right, 2 more questions. How do primary colors of light produce secondary and what's called complementary colors? And then last, how does amplitude of a light wave determine its brightness? So keep those topics in mind. Okay, here is the electromagnetic spectrum that I mentioned earlier. The part of the electromagnetic spectrum between infrared and violet, so from here to here, that is visible to the human eye is what is called visible light. So if we can see it, it's visible. That makes sense, right? Okay. Shorter waves have a higher frequency and energy, and longer waves have a lower frequency. Okay. So just like with sound, if they're more frequent, they have more energy. Okay. The visible light spectrum, so what we can see, is produced when light passes through some sort of prism. Prism is, as I'm sure you've seen it, looks like this, it's glass. And that slows the wavelength into each separate color. I don't know if you've ever heard this in art class or sometime, but the colors are called Roy G. Biv. The R is for red, O orange, Y yellow, G green, blue, B indigo, which is the I, and then violet. So if you ever, someone says, what are the colors? You can say Roy G. Biv. All right, there's the colors of the rainbow. It's a beautiful rainbow. Each color has a different wavelength and a different frequency. Red has the longest wavelength. As you can see over here, it's very long from peak or crest to crest, peak to peak. Okay, violet has the shortest. You can see down here, there's a very short distance. Okay, and then seen together, they will make white light. Okay, things that we can see. Visible objects. For an object to be visible, it must produce its own light or reflect light. Things that produce its own light. Yesterday, the cartoon called that natural versus artificial. But things that produce its own light, sun, candles, okay? Things that reflect light are the moon, a mirror, glass. All right, vocabulary. Very important that you know these words. For the kids who were at school yesterday, we talked about these quite a bit. Opaque means something that reflects or absorbs all the light. You cannot see through it. Okay, you cannot, light does not get through it. So like a piece of wood, metal, cardboard, a desk, anything that doesn't let light through is opaque. Then there's transparent, which would be like a window or glass, anything that lets light clear through. Then there's a middle class called translucent, and it lets light through, but it scatters it a little bit. So something like wax paper, frosted glass, thin fabric, anything that allows a little bit of light through. Okay, cute little kitten up here. How light travels. Light always travels in a straight line, but it can be reflected like a mirror, diffused, so kind of spread apart, refracted, which I'll move, is when it bends and or absorbed. Refracted would be like when you see a straw in a water glass and it looks like it's bent. That's what we're talking about on refracted. All right, so here is reflection. I'll go back over here. How about if I go up here? I'll keep moving around. Reflection occurs when the parallel rays of a light hit a smooth surface. So, like in this case with the kitty cat with the mirror. Okay, all the rays are reflected at the same angle. All right, there's something called the law of reflection, and that's the angle that the reflection equals the angle of the incidence, meaning it comes in at one angle and it goes off at the exact same angle. Okay, we won't spend a ton of time on that, but that's just something you need to know if you hear it again later in your schooling. And then the angle of incidence is the measure of the angle of the ray normal to 90 degrees. Again, just a term I'd like you to be familiar with, but do not to spend too much time worrying about it. There we go. All right. The second thing that can happen to visible light is what is called diffusion. And that's when they hit a bumpy surface. If you see over here, so like a mountain or ground or whatever, each ray obeys the law of reflection, meaning it bounces off. These arrows pointing down mean then it would point back up. Okay, but it hits at a different angle, so the light is scattered or spread out. So that is diffusion. Okay, we will stop there for today on the refraction slide, and we'll continue on with that tomorrow. Again, go back through the PowerPoint as many times as you need to answer the questions, and make sure you get those questions done today. Again, you get tired of hearing me say this, but you need anything, message me through Canvas, and I will try to get back to you ASAP. Have a good one. Take care.